To Science Direct, Shannon's entropy is defined as a fundamental measure in information theory that quantifies the uncertainty or unpredictability of data distributions. According to ResearchGate and Medium, Shannon's entropy has the ability to measure randomness, diversity, and fairness, which makes it applicable in optimizing systems and solving real world problems such as data compression, communication systems, cryptography, decision making, and machine learning. So, what is this fundamental and versatile question? Ta-da! Entropy h of x equals the negative sum of p of x multiplied by the logarithm to the p of x base 2 for all possible outcomes of x. To help you understand, imagine a random event x with several possible outcomes, each happening with a certain probability p of x. The logarithm with base 2 tries to find the surprise or information content, hence in entropy, h of x. The result is measured in bits. The higher the bits, the more surprising it is due to the low probability. And the lower the bits, the less surprising it is due to the high probability. Here is an example. In short, the summation in the formula adds up the uncertainty or entropy for each outcome, weighted by how likely that outcome is to give the overall average uncertainty of the event. Let's break it down into simpler words. This equation measures the uncertainty or information content in a system. In our case, if the amount of donations is sufficient. For our case, we are going to solve if the donations are sufficient. We can do 365 units of food and water, 188 units of clothing, 200 units of hygiene, 308 units of medical supplies, and 257 units of other items. We will sum them up, which is 1,318 units. Now we will solve for its probabilities by dividing the amount we have over the total, which results in these units. By applying the formula like so, we can determine if it is sufficient or not. In this example, a 5-category entropy, it is considered moderate. So, we are currently still in need of more resources in other lesser donated categories, such as clothing. Hence, Shannon's entropy is very efficient and significant in real world situations.